Hi, Anu. Mike here.
Hey, Mike. Thanks for joining.
Is it okay? Is it okay? Shall I share my screen?
Yeah, we usually start at the 3 minutes past the top of the hour.
Yeah.
So you could wait a bit if you wanted.
I'll just share it now and then it's ready for when you want to
Sure,
start.
sure.
Make sure it works. It's always good
I know.
to test it in advance. So you should be seeing a blank screen, but now you should be. So I've got a PPT to present as well. Okay.
Yep.
Okay. I'll just leave that up until we're ready to start. Okay. Thank you.
Okay, we've hit our magical time, 8:03.
Yeah.
Welcome everyone to today's meeting. A few weeks ago, JP had presented the proof of concept that was done a few years ago, maybe 2 years ago, and it was the concept of um, what he calls a pitchlet concept, which is not quite a chiplet because they were actually chips, but they created the Mara board, and they put together Broadcom chip, um, NXP and Lattice. I don't remember the other two, but the goal was to have a framework such that a system people could put a chip in for testability. Now, of course, the most obvious step after that is how do you do that as a chiplet? And there is some starting barrier or hurdles to the chiplet concept for people to test it, cost being one of them. So an ability to prototype sounds like a fantastic idea. So Mike's got some thoughts on this. He has put together a slide deck along with John, right, John? John Fryer was part of this. So
Well, and honestly, all I did was just make a few suggestions to Mike. I really don't deserve a whole lot of credit. He's done the heavy lifting on this. But
okay,
thank you for the mention. I appreciate it.
yeah, anytime. So that's what we're going to talk about now. Cliff is on the call, so I want to first go through any logistics and events that Cliff wants to mention to the group?
Hi, everybody. I think just a quick summary for EMEA Summit happening April 29th and 30th. We did have 2 chiplet related proposals for speaking, and I believe they were both accepted. And they will be presented in a track on IT infrastructure, which will combine server storage and networking at EMEA Summit. So there is some representation. I believe it's Tony from Siemens that'll be presenting, and the other proposal, I can't remember, Anu, who was it from?
It's actually Mike from TESOL, Mike Bartley.
Oh,
Okay,
yeah.
perfect. So glad that you can make it and speak. And then we have formed the program committee for OCP APAC Summit. That is going to be August 5th and 6th in Taipei City. So Anu and Jawad, along with Bill Chen and a representative, I think Dr. Lowe from ITRI, have agreed to be the program committee for that full day track. And we will be doing a hybrid model where there'll be a mix of key invited speakers and a call for papers going out. Call for papers will go out in May. I think it's May, maybe a bit earlier. My apologies, we haven't decided the exact date yet, but I'll get back to you on that. So for anyone that is interested to come to Taipei City and present as part of this full day track on chiplets and semiconductor packaging, please think about putting together an abstract and submitting. We'd be happy to have as many people as we can come out to Taipei City in August. I think that's it for the announcements for now.
Thanks, Cliff. Appreciate it. I think we've got quite a quorum to get started, and just wanted to welcome Rob Pelt from AMD. Had my first chat with Rob yesterday, and thanks, Rob. Appreciate you joining the 8 a.m. meeting. I know we have the 10 a.m. today, but good to see you here.
Thanks. Glad to be here. Thanks.
So, Mike, you want to get started?
Yep. Yeah, I'll run until 1/2 so I'll keep to the timing. So this is just an idea. I think I was in the call 3 or 4 weeks ago when people were saying that especially the small companies need some way of potentially, either prototyping their chiplet or building some route to cheap silicon so they can they can get an early chiplet rather than just do everything in simulation, and they can start to connect up to other chiplets, for example, and start to put together prototype systems. So this is just an idea. It's there for discussion. It's not set in concrete, and people may say, well, I don't think it's a good idea. I don't think this is a runner, so more than happy to drop the idea if we don't think it's if it's going to get any traction. So a completely open discussion. Anyway, so the agenda here, I'm just going to go through these 4 topics, look at the issue, the opportunity, what are the limitations and possible solutions to that, and what are the next steps. So this is based on an assumption that startups want to prototype their chiplets for either testing purposes. They just want to test it. Can they that would mainly be functional, but can they interface to a UCIe or other interface and then connect up and communicate with other chiplets, or even with their own chiplet? Okay, so quite often a lot of companies we work with want to do testing of their chiplets. And the just for your information, TESOL is a services company, and we are working with quite a few companies already building chiplets. At the moment, most of those are fairly large companies, and typically they're developing a system made up of their own chiplets, so they're not reaching out to other companies and trying to integrate their chiplet with other companies. But obviously for smaller companies, that's probably going to be more the case, that they can't build a whole system from their own chiplets. They've got a particular chiplet which they need to interface to others. Okay, so that's the sort of testing we're looking at. They also quite often want to do a demo. It's very difficult to win customers if you can't demo what you're building, what you're proposing, and that will help with client engagements. So that's the idea, is that to give them some way to prototype their chiplets. And a lot of companies that we speak to, one of the barriers to that is the cost of the interface technology. So for example, most of them are working in UCIe. So most of the companies are adopting the UCIe interface because they think that will give them that particular interface has got more traction in the market, and therefore they're going to have a lot more chiplets to connect with within the ecosystem. So they're really focused on UCIe, but they're not building that interface. They're relying on third-party IP for that, which can be very expensive to license and go to market with, even for a prototype. So there is that's what's it's become to some of the limitations. They do need that UCIe interface IP. Typically, they're gonna end a digital interface into that and allow the IP then to add on the PHY, etc., so it can connect out. They've got limited budgets, especially compared to bigger companies. They typically got much smaller budgets. They typically want to run at speed as well, so that they want to try and get this to run at a decent speed. Quite often they're running software, and they want to prototype a system that's running software. So not just for chip verification. Quite often they're doing hardware, software, co-verification, which needs some at-speed simulations that are. And as I say, they do want to interface to other chiplets for testing. So there's a chance that they can actually try to integrate with other chiplets. And they want to implement their own design. So as I said, they're probably going to interface to the digital side of this IP, and then let the PHY take over the communication to other chiplets. But they probably want to interface to the digital side of this, and put their own design into that prototype. That's what they're trying to do. They want a demonstration platform of their own design, that's interfacing to probably some standard industry IP, which they can license, but that would be expensive. So what are the possible solutions? At the moment, really, the only solution is to try and develop their own silicon. That's the only one I'm aware of that's really in the market at the moment. And some companies are offering programs to do that. I know John before the meeting mentioned AMD. So some companies may be offering silicon, maybe cheaper silicon solutions by partnering, to try and build up the ecosystem. That's still quite an expensive route though. So what I looked at and was potentially looking at off-the-shelf silicon. Obviously, off-the-shelf silicon may not be as flexible as you want, but if you can buy off-the-shelf silicon that has the UCIe interfaces and the FPGA fabric, then what you've got is that external UCIe interface, and you've still got the flexibility to build your own design on that FPGA fabric. So this seems to be, to me, an ideal prototyping platform that those smaller companies could use, could deploy, and put their own designs on there, and then connect up to other chiplets via these UCI interfaces. You may not need that many, and what I've been looking at and I'm talking to is there's a couple of companies, Your Chip, are partnering with Quick Logic. So Your Chip are providing the UCIe interface for that chip, and Quick Logic are providing the FPGA fabric, and they're actually producing silicon. I think they've produced their first prototype silicon, and if I buy that, and I've spoken to Your Chip, and I know the Your Chip join a few of these calls. Cash from Your Chip is actually in India at the moment, couldn't join today, but I know he joins these calls occasionally. He said he could provide that silicon at about 5K per chip. Probably if you buy it via Quick Logic, it's going to be a little bit more expensive. But Quick Logic will be producing this silicon and selling it into the market. So there is now this potential route via FPGA fabrics here with the UCIe interface. And obviously that needs to be packaged up, because you want to be able to put multiple chiplets then onto a single package. And again, speaking to Your Chip, they have a specific partner who can work on an interposer, possibly to do a UCIe interface, a UCIe interface. And he's given the example that they could put 4 chiplets on there and connect those chiplets up via that interposer. He estimates that interposer will cost about 200K, and then obviously the 20K for his 4 chiplets. Alternatively, I've spoken to internally within TestSolve. TestSolve 2 or 3 years ago worked with OCP and put together a package based on I think there's about 8 chips, 8 chiplets communicating over BOW, and that was just a sort of test to see that they were from 2 different vendors, both had BOW interfaces, and we connected them up to show that those chiplets could communicate to each other, and that was done on an organic substrate rather than an interposer. That would probably support UCIe S, obviously slightly lower cost, and we expect a 50K NRE to design the package, and then I'm still trying to get the cost of what that package actually might be, and that's still being estimated at the moment, so I can't give you that cost, but I wouldn't have thought it's that expensive to get to actually buy the packages once they're done. You're again speaking to Cash from Your Chip. He's suggesting that what they could do on here is put some external. You obviously need an external interface as well as the UCIe. UCIe is going to communicate to other chips, and he would suggest that you could put a very simple external serial interface, so that you could go off package with some sort of a simple GPIO or SPI type serial interface, rather than anything too expensive to get off chip or off package in this case. Okay. In terms of availability, I've been speaking to Quick Logic. They were expecting 2025, and I'm not sure if they've met those expectations. And the chiplets will range in size from 40K LUTs to over 1 million LUTs, and that's obviously key as well, because it dictates how much of your design you know, how big is your design? How many LUTs will you need? I'm told again by Microchip and Quick Logic, there is going to be some on-chip RAM. So these chiplets do have RAM. So if you wanted to not a huge amount of RAM, but that means we don't have to interface to an HBM, for example. We did discuss whether we could interface to an HBM, but that makes it very expensive. So we could use some on-chip RAM that's got some to run software and to load software from. So that would be solved as well. And these are the size of LUTs that you could be available. So I guess for me the main question is this really needed? You know, is there a market for this? Do people want to do this? Or they if there is, then you know, have they got the budget for it? Are the solutions suggested viable? Could we build this UCIS, or could we actually go to the more expensive UCIe? I know some of the feedback was that this looks a little bit on the cheap side. Then the numbers I've been given by your chip, and this NRE is the numbers I've been given by TestSolve. So these aren't plucked out of the air. These are numbers that have been qualified with the suppliers. So it seems affordable. But what would be the commercial model for development? I mean, your chip probably aren't gonna speculate with a 200K development. They'd probably want some commitment in advance. Similarly, TestSolve would want some commitment in advance before they did a design of a package. So that means that there needs to be a more complicated. The commercial model is a lot more complicated. It's not just that your chip or Quick Logic or TestSolve are going to go out and build boards and then try to sell them. They need some level of confidence that whatever they build is going to be a market for afterwards, which is obviously going to complicate the commercial model a bit. Okay, and that is all I had. So this was really just to throw it out there and get some feedback. Okay, so I will finish there and hand it over for discussion.
Thanks, Mike. Could you go back to the slide that shows the FPGA in the middle and the UCIe chiplets, please? Yes, thank you. So I just had a few questions. So what you're saying is, if I've got a chiplet idea, I can use the FPGA fabric to represent that chiplet.
Yes.
And it would be a certain form factor because you're trying to fit into an existing package.
Yes.
And then your chip would provide the by 16 UCIe as a chiplet?
No, this is a collaboration between Quick Logic and your chip. So this picture is the actual chiplet. So effectively, Quick Logic are providing the fabric. Your chip are providing the UCIe interface, and it's all integrated onto a single chiplet. Not on, so this is one chiplet, and then you could put down multiple, multiple of these. So basically, what you're going to do, what you're going to get is this chiplet here.
Yeah.
And then what you're going to be able to do is go away and generate your FPGA, get a bit stream. And that's why you need the on-chip RAM, because that bit stream needs to be stored somewhere. So you could put that bit stream into an on-chip RAM in here somewhere, and then program the FPGA, and then effectively your design is inside this FPGA, and it's communicating to the your chip interfaces within this chiplet.
Okay.
And you should be there now to. So if you've got two of these interfaced together on the package, then they should be able to talk to each other. Now, what you put in the other ones is up to you, because you obviously need. Yeah, if I'm going to try and communicate with another chiplet, that chiplet needs some logic to be able to communicate. So, whether you could put some dummy design in here to communicate with, I don't know, but certainly you'll be able to prototype your design based on this limitation that you've got a certain number of LUTs. So if your design is too big for the FPGA, you're not going to be able to get it on there. You're obviously limited to digital, right? There'll be no analog on there, but all the analog should be in this PHY here on the UCIe, and then that allows you just to focus on the digital design inside the FPGA.
So this is effectively a block diagram of a chiplet. Is
So,
that
so
right?
can you speak up? I didn't catch it.
Is this a block diagram of a chiplet
Yes,
that you're proposing? Okay, so it's really
it's not that I'm proposing. This is actually going to be made by QuickLogic and your chip. So this is a commercially available chiplet.
be available off the shelf for others to use. Thank you.
Yeah. And that's the key thing, it's off the shelf, and therefore you haven't got to go away and do your own silicon, and go to a lab and produce all the mask sets, which is going to be very expensive. If you go down this route, it's going to be very expensive unless you can find a partner who's going to do the tape out for you. So this is an off-the-shelf chiplet
So
that will be available.
is this UCIe or UCIS? I mean, you talked about both versions. So which version is going to be manufactured?
So
Both?
my understanding is that your chip are talking about both versions being available
Okay, thank you.
on that chiplet. So UCIe and the UCIS both available on that. That's what I'm told. Obviously, I've done as much qualification on this as I can, but I haven't actually seen, although QuickLogic say early 2025, I haven't actually seen the announcement. So I've not actually seen if we've got a real specification of that.
So Mike, this is quite interesting. So and this is going to be offered as a standard product, you're saying, for anybody to use inside their system. Do you know if any companies have signed on to use this?
No, I guess that's probably just commercially confidential to.
Oh, okay. We'll wait for the announcements then. Yeah, don't contaminate us.
Yeah, I haven't seen the announcements. Last time I spoke to QuickLogic, they did say they were on target for 2025, but when early 2025 becomes mid 2025, I don't know. But maybe they could still argue that Q1 is early. I don't know.
Yeah, the only reason I ask is I mean, I've heard about this, but I haven't seen this implemented anywhere. And of course, as you know, we do lots of chips here at ASE, ISE. And so I guess when it comes to fruition and somebody announces using this in their system, we'll hopefully see it come across.
Yeah, and so I'm looking for announcements. I haven't seen any yet. And also obviously the Intel and AMD could be doing this as well with their FPGA fabrics. I haven't seen any announcements from Intel or AMD on this either. So although I think Intel have floated off Xilinx, haven't they? Or was it Altair? I can never remember which way around it is. But obviously QuickLogic aren't the only FPGA fabric.
Somebody might want to come along to the Atomic Ethernet Workstream and talk about the FPGA stuff there. We've got I think a Thursday meeting where we discuss FPGA for communication stuff. It seems like that thing's a big hub.
That's the Atomic.
The Open Atomic Ethernet Workstream. So Paul Borrells.
Thank you.
A quick understanding question. So you called it a chiplet, but it's a package, so it becomes a chip, right? The product
Well,
will be a chip, which is on
that's
the
correct.
motherboard.
That's correct.
Okay.
At this point here, it's a chiplet. So this is a chiplet.
Yeah.
And then when I package them together, whether you want to call it a chip or a system, but yeah, it's when you package it that you've effectively got a chip or a system, and then but with those four triplets communicating with each other, and that's what I've seen people doing. As I say, we've worked with quite a few customers, and that quite often they're calling them multi-die packages, MDPs, where you put multi-dies, and those multiple dies are sat on some sort of substrate or interposer communicating with each other. And that package, there's some then external interface. The companies we're working with usually have some sort of a PCIe. The external interface is a PCIe, but again, that's expensive. So that your chip is saying is that, yeah, we could probably put a much cheaper serial interface rather than
So
go to
who
the
will be,
PCIe.
the reason I was asking this question is I want to know who will be responsible for packaging it, because these are really the silicon. So from the wafer, you get the silicon, you have to ship it to a OSAT. How would that process work?
Well,
Because there's one.
Yeah. So that's what this here, this 200K, that's there's a your chip partner who will be doing the packaging and the OSAT, and for TestSolve, if they do the NRE, which is the design of the package, okay,
Okay.
then obviously they're going to have to look for a partner to do the manufacturing of the package, and then whoever's doing the manufacturing of the package become your supplier. So your chip and QuickLogic are just then part of the supply chain rather than being the final supplier, and it's the package company. The package manufacturer.
So that package company would be us, by the way. But anyway, so the 200K seem sorry, sorry, you were going to say something. Go ahead. I think I interrupted somebody.
No, go ahead. I was just saying I'm getting some sense, but since you're from packaging, I would love to hear from you.
Yeah, so it's actually so the 200 does seem a little bit on the low side. So typically what we're seeing is so I mean, if we go to the next level, what you have is, you got the substrate layer, but the substrate layer, people are just designing a new wafer, which they call their base layer. And that new wafer could be like a carrier wafer, if you will. On that carrier wafer, and this is where we've got these crazy initiatives of going, I kid you not, 200 by 200, 200 by 400. So 200 by 200 is the size of one wafer with the edges cut off. But anyway, not to get into details there. So what we do there is then you take chiplets like this, you put it on that base wafer. So it may take 3 different wafers to build this thing. So you've got the base layer, you've got the HBM, and then you got like all the controllers, like your compute die. You've got this UCIe, and that all goes on the base layer, and that's how it all gets built up. And that gets packaged. So and we don't have that 200 by 200, of course. You can make your base layer with the chip, where the base for the chiplets could be 30 by 30 or something, or 30 by 40. So obviously it's bigger than a reticle size, and then there's interstitching to connect those. But we don't have to get into that. So that's kind of what we're seeing, how all this comes together.
Yes. Yeah, that's useful to know. Yes, good education. I think I think what we're saying on this is that probably I've pushed back on that 200K because it does seem low, and I've had other people say, "Well, that looks a bit low." Apparently, this partner that your chip have got new technology that reduces the cost. I don't know where those red lines have come from. Sorry, I don't think they're me. But
I wanted to ask JP his opinion, given he's done the first proof of concept with actual chips. I think one difference I see is that was an actual interop where a board had 3 chips. This one is sort of unique. So JP?
Yeah, hi Anu. Hello everyone. So yeah, I have a few questions. The POC earlier we were considering is actually we want to have chiplets, and we were only focused on building that PCB platform and the package for evaluating that, right? For mainly for interoperability test. So Mike, what is the you have another slide, right? That you have proposal, the last slide. What is it for? Is it for the entire platform, including the chiplets, or what exactly the proposal here is?
You would buy that package. So you would buy a package here. And it may be that the buying it as a PCB may be much a much cheaper solution. You don't actually have to go to a single package. You could do a PCB and put multiple
Okay.
chiplets on that and then connect them up on the PCB. That might be a much more viable and cheaper solution than going to an interposer.
Oh no, I'm not saying substituting the interposer, but if once you package it, you need to have anyway the PCB platform.
Oh yeah.
Right. And so if I understand you right, what you're proposing is actually a standardized UCA chiplet being made available to the community.
Yes.
Is that the right? What is the value, the key value you're seeing in this?
It allows people to do prototyping because it allows people to put their design onto the fabric and then try and communicate to other chiplets. So
I see.
So I guess your question is why not do a custom one versus just getting the standard one? Yeah, you can do a custom one, but it's going to add a little bit of cost. But here you've got an infrastructure you can already work with the proposed standard.
yeah,
Okay.
this
And
is
like Mike said, for prototyping, I mean, this is so invaluable just to not worry about this piece and just get it, plug it in, you're done.
Mike, I have one question regarding the cost that you have in the next slide. Yeah. So that one. So when you say 200K, that is four chiplets, right?
it's 4 chiplets on an interposer packaged onto
Oh,
an
okay. So
interposer.
it's the 4 chiplets and interposer,
Yes.
but they are still not packaged, or they are already packaged.
Well, the chiplets aren't packaged because they're going on as raw die. But the interposer is packaged, yes.
So let's say that I go into something called like similar to DigiKey or something like that, and I order this. What I'm going to receive it is 4 chiplets and an interposer. That is what I'm getting
No,
before.
you're going to receive an
Sorry.
interposer with 4 chiplets on it already packaged.
That's 200K.
Plus the 20K for the 4 chiplets, yeah. But it's all packaged together. And again, that number does look low. And I think it's low. 2 other people I've spoken to think it's low, but your chips say no. So it'd be great if Cash was on the call because he could validate this number. But that's the number he's given me. But you pay 200. You effectively pay 220K, and you get the packaged interposer with 4 chiplets. The reason I separated out the cost of the chiplets because if you then said, "Oh, I'd like to have 8 chiplets," then that might cost you 200 plus 40. If that interposer was available as well.
But then the connectivity between the 4 chiplets is already set, right? So
yes.
okay, and
it's UCIEA. They'll be communicating over UCIEA.
And the 4 chiplets will be connected like in a grid.
Yes, on the interposer. The interposer is doing the connection between those 4 chiplets.
Okay, that's it. Okay, yeah, thank you.
And also, Mike, that the block diagram that you have, right? Can you go to that page where this one? So you're saying by 16 UCIe, that is actually good for a standard package, but if you're an advanced package, that is too low. So I don't know, maybe you have a different diagram. Yeah, right. That might be what thinking about it. If you're going with the advanced package, do we have additional bandwidth available?
I don't know. That would be a decision for your chip and QuickLogic to see if they would want to produce that.
But it's not one chiplet packaged in a single package, right? There are 4 of them. So you're going to have really a lot more than just one UCIe by 16 interface. Is that correct? I mean, based on what you were showing in your next slide or two, that there are 4 copies of the same chiplet that is getting packaged.
Right.
You're talking about all 4 sides, right? By 16, 4 sides.
But there are 4
Yes.
copies of the same chip in the one package.
So Rita, I agree there's 4 copies, but I think JP is just saying between any 2 chiplets, the connections of I-16
Yes.
UCIe,
correct.
that's the total bandwidth.
Yeah.
And he's
that's
saying that's
true.
not enough.
That's
So
true,
the-
between chiplets,
Yeah,
correct.
he's looking outside of this block, essentially. He's saying for this to talk to another chiplet. So I think JP, what needs to happen is there needs to be one definition, like a fixed spec saying if you're doing advanced, this is the density you get on north, south, east, west.
Correct. Yeah.
And this is the max data rate, 32 gigabits per second, whatever the heck you want to run it at. And then if you're using a standard, this is the beachfront, this is the bandwidth at each beachfront. And this is the max data rate. So it's kind of, I think there's got to be 2 spec. One offers you very high bandwidth, the other one offers you not as high bandwidth. And you get to choose which one you want to do. But JP, in my understanding, is this whole thing is fabricated as one die, right? The FPGA fabric is built with the UCIes in it. We're talking
Correct.
as if each of these are chiplets inside this. That's not the case.
Yeah.
This is
My
a single
understanding.
die. Yeah, single
Yeah,
die.
go ahead, Mike.
No, just yeah. This is a single. What you're seeing here on this picture is a single die.
Yeah, the entire blue box is single die. So, Mike, also, what is this by 4 links that on the
Yeah,
green boxes?
I was gonna ask.
Sorry.
So you have a by 4 link, right, on either side of the UCIe block. What are those?
I'd have to get back to your chip on there. I think there may be 4 UCIes giving you a total of 16 UCIe interfaces, which seems a bit over the top to me. But
I see.
I mean, my guess is
there's no
it's a
data
different.
sheet. There's
it's
no
like-
data
it's a-
sheet for this at the moment.
it's a
so
different
it's probably
interface.
difficult to get all the details. But there's no until we get a data sheet, it's difficult to know exactly what's on there. Sorry,
So,
go ahead.
Mike, one question. This blue box that you were showing for 200K, are you customizing for everyone? Because that would be like $500,000 tape out cost.
What
So,
do you mean by customizing?
so is this a standard block
Yes.
or standard chiplet?
Yes.
So that means whoever builds a system is limited by whatever functionality is in this fabric.
No, because it's an FPGA fabric, so
No, I
can-
mean FPGA, but not single solution doesn't fit all, right?
But yes, Jawad, this is a product offering that's a fixed number of fixed fabric and UCI ports and stuff. Yes.
yeah. So
I mean, they're looking at
Customized
different.
up-
Yeah, it's not customized, it's FPGA, but there may be different offerings they do that are different sizes. That's
Yes.
what most FPGA companies do, but
you can see
yeah, the
here-
idea is a fixed product you can buy like FPGAs, except it's a known good die chiplet instead of a
Yes.
packaged chip product.
Okay, got it. Thank you.
Yeah, so you could choose a slightly different sized FPGAs. Because obviously the 40K to 1 million LUTs is going to give you some flexibility on how, depending on how big your design is, and they're going to be different costs based on the number of LUTs. But the flexibility is all built into this FPGA. Everything else is fixed. And obviously the size of the FPGA is fixed. Your flexibility comes from the fact that you can create your own bit stream and therefore program the FPGA in different ways.
Yeah, so that's my understanding as well, is the interface that you have is fixed, and you have some controllability of the FPGA if you want to do some special things or control special things. Now, they also offer a standard product with a recommendation saying, here's how you should do your interconnectivity using this particular chip. But the flexibility, there is some flexibility. But Mike, doesn't Xilinx have an initiative on this as well with their standard?
I've looked, I didn't find one, but they may do. So, but I've tried to find one. Seemed that Quick Logic were the first to market with this, with your chip. So
Okay.
my research hasn't turned up a Xilinx or an Altera AMD solution. So TBD on that.
Okay. I mean, I know they have an initiative. I just don't know if they've announced. Let me find out. I'll follow up with you.
Yeah, that would be useful. I mean, the more you can tell me, it'd be great if there were multiple FPGA companies doing this and competing on it. Because also then what you could do is put down, one from Xilinx, one from Altera, one from Quick Logic, and see if you can get those to communicate with each other. But
And do you know if Altera? I haven't looked into Altera at all. Do they have something comparable?
not that I could find, but my research may not be as comprehensive as to rule that out. I don't think I couldn't rule that out. It's just I haven't seen that.
Hey, so a couple of comments. So I've put in the chat a link to an announcement that your chip did about a breakthrough to the chiplet packaging technology. If reading between the lines, that's probably where the costing out of 200K is coming from, is from that relationship. But again, I'm reading between the lines. I don't know that for a fact, but might be interesting if folks took a look at that. On the AMD side, they have recently published a chiplet ecosystem white paper.
Yes.
That is pretty nice, actually. I think it's worth taking a look at.
Thank you. I wrote it.
Oh, did you? Okay.
Yeah, I appreciate that.
Yeah.
Can you guys send a link to that? That sounds interesting.
All right, we're going to get on a race here.
Okay, so I think this is the one we're talking about here. Yeah.
Yep, that's the one.
Yeah. So AMD chip.
You could paste the link in the chat. That way everybody has access to it. It's amazing. We've got the author of the white paper here. That's pretty good.
Well, I think John, you were pointing out that page 6 was the interesting one.
I think it's actually at 7.
7, sorry, let me slide down to 7 then.
And here's a link to the white paper.
Yeah. And so there's a partnering opportunity here.
Yeah, if you scroll on down, there's a little block diagram that they're doing that you may need to reduce your scale a little bit. I think you're missing it. It's over to the right.
Maybe above
There.
this one.
Yeah. And so really, if I understand this correctly, there's an opportunity with the right volume and the right customers upstream to partner with AMD and basically create a system on chip that's using a third-party chiplet, which is an industry breakthrough from my perspective. And it actually occurs to me, Mike, is that maybe the prototyping scheme you're talking about here could be a potential feeder to this, because this is a pretty big step jumping to here, so you might want to do some preliminary work.
Yes. Yeah, my guess is that taping out via AMD is going to be more expensive than buying an off-the-shelf FPGA to play with, but I don't know.
I will say that our costs will be significantly higher than what you were showing on your slides. But we're also our technology is, when we wrote this white paper, or when we talk about AMD Anchor, we're really talking about, basically our server, maybe our MI chips, right? So those are cutting edge silicon nodes, which are very, very expensive.
Yeah. And cache is or cache is really focused on more of the lower end
Indeed.
market. So you two guys are a little bit orthogonal, that's for sure. He's where
Yeah,
the
that's definitely not the market we're expecting to play in. We just don't have the cost structures to do it.
Yep.
Hopefully somebody will. I think it'd be great for the ecosystem if there was a lower end capabilities.
So Rob, can you say a word about when do you envision AMD might open this up for volume manufacturing where other chiplet providers can be part of the ecosystem?
So we're working on it. I mean, I think like I just had met Anu for yesterday for the first time. What we're seeing, the barrier is like the UCIe, that stuff, that's the simple stuff. It's actually how do we integrate power management and RAS and security, and there's no real standard for that. And we don't really want to push all of our stuff out into the ecosystem just because, we've got a lot of legacy and it needs to be built up. So I'd say, closely working with people, we do that now, but for an open system, we need to get a few more things going. So there's more standardization needed.
Great, thank you.
Yeah, I don't have a timeline because it's really the timeline is basically like people on this call. How fast can we get, enough standards together and infrastructures that will allow this to happen? From AMD's side, we want this to happen as quickly as possible.
Okay.
So, question for AMD. This is a very interesting idea. What is the service or business model for AMD? Will make the chiplet available for third parties to integrate, or AMD will integrate from the third party?
Our first pass at this would be we would do the integration. We just think it's a big step for us to sort of release all these chiplets in and expect somebody to be able to integrate them and test them and productize them. Right? These are very complicated. Yeah. And providing a test suite and a post silicon validation suite is a big uplift for us. So we're not quite there yet.
And will it use a standard UCA interface, or what interface you're?
That's our plan. Yeah, our plan would be this would be UCIe. We do have some internal proprietary ones that could use depending on latency and things like that. But our real hope is for this third party is we'd just be UCIe. Sorry, we're not really looking at a bunch of wires. We're highly ingrained in UCIe. I attend 3 to 4 meetings a week on UCIe.
I see. And also, sorry, one more question. Do you plan to publish the specs for integration, or what's the plan around that?
Well,
to get
that's
more
what
around it.
Yeah, so that's our hope is that that's where we're trying to spur more standardization because we'd like the specs to be from the community rather than us publishing everything. We're certainly willing to provide help and give what we have, but we think it'd be better if it's sort of outside and we say, hey, we support this standard because it's really hard for us to support individual customers with individual standards, our proprietary standards.
Okay, yeah, that makes sense. And also, do you plan to do this through UCAE or it's an external body for the standardization?
Well, that's what we're trying to figure out. I mean, that's why I approached OCP, earlier, which is I think there's some things that UCIe has down. And like you said, most people are gravitating towards that. So there's the PHY, and then there's sort of these plumbing services that are coming out,
Right.
like how to get data across, how to do discovery, those kinds of things. But I think there's the next level, which probably is better fit outside of UCIe. Like, there's firmware and software standardization that needs to happen. So that's kind of why I was looking to maybe OCP might be a good place for that.
Mm-hmm.
Hey, Rob, another question, say, most of the challenges when you start integrating various chiplets in a package to show up. So is there any plan to just have a chiplet package itself, and then on the PCB, we route it with another chiplet, which is also packaged?
I mean, that's I don't know, to me, that's what we do now. I mean,
No, I mean
that's
through UCI.
that's just two pieces of silicon packages on a board, right?
Sorry, I meant through UCIe. I can use retimer or I can bud them
Oh,
together.
yeah, I mean, I guess we're not really highly invested in UCIe external, because we have a million other things that we support already, right? We have PCIe, we have Ethernet, we have, we're I don't know if folks are familiar with UAL link.
Yeah.
Right, so those are the types of things we're doing. UCIe is not, UCIe external is not something we're really looking at because we haven't really seen much demand for it.
Okay, thank you.
Okay.
No, this was a great discussion. Going back to what Mike showed, JP, does it in any way line up with the vision you had for the proof of concept workstream, which we'd like to try to revive if there are good ideas and there is opportunity to put stuff together to enable people to verify their chiplets on a
Yeah, so yeah, good question, Anu. I think certainly it aligns well, right? I think our goal mainly when we started the POC work a couple of years ago, the main goal was to standardize on the PCB platform, bring up software, and standardize that. It's somewhat similar to what AMD is talking about, but I think that we need to uplift that to a larger scale. But if we look today, I've been the ISSCC a couple of weeks ago and other conferences. Everybody's demonstrating chiplets. Everybody has their own platform, their own software, right? It doesn't have to be like that. It can be all standardized and with one plus. So the lot of reuse can be true reuse can be benefited only they are standardized. Both hardware and the software bring up platforms, right? I think that this gives an opportunity what Mike is proposing and what AMD is in the white paper, that brings the opportunity where we can come together and standardize on that part, right? Both hardware and the software.
Yeah,
and
agreed. I think sort of everything is happening in somewhat a timely manner, starting with when Durgesh asked about system level concerns, and then AMD reached out with their firmware initiative, and then we've got the proof of concept. I think everyone's going to struggle with all of these problems sooner than later. And
right, yeah.
if we can build some standards with those who are, sort of in the on the fringes of exploring this, it would be great. The other thing, JP, is I fully understand why UCI is being used. I fully understand why AMD uses it. But for the bunch of wires, we're looking not just at the high end, we're looking at providing to the lower end markets too. And this prototype could then use a bunch of wires, the Flexi one that actually cache from your chip proposed, for lower data rate. And that would just be standard packaging. So the cost of interposer and all of that goes away. So I'm thinking we can actually extend this similar concept or whatever we come up with eventually for other applications other than the HPC AI ML, which is the hot spot right now and the sweet spot. But as other folks start looking at how to use it, and cost is the biggest barrier at that point. So
yeah, certainly, I know. Yeah, I agree. We should build a scalable platform that supports from low end the edge market to all the way to the data center.
right, exactly. So Mike, these slides, I think before we share them, we should probably check with Cash if he's comfortable with the numbers that he has, before we send it out into the ether.
Yeah, I sent the PBT to Cash. I haven't had feedback yet, but I'll sign these off with Cash, and then put them. Then you can share them. I'm keen to know what the next steps are. I think we've had a good discussion. I'm not quite sure we ever got around to.
To be honest, I'm not sure either what the next steps are, but I think we'll get more clarity. At 10 a.m. Pacific time today, we've got this smaller focus group on what the system level looks like, and AMD is going to join that meeting today. JP, hopefully you can come too, and we can sort of lay it out on the table and see what are the pieces that need to be addressed, how and when we can go about doing it, and then maybe we'll have more clarity on this. But this was really great, Mike. Thank you.
Sure.
Appreciate you taking the time to put this together.
Perfect, perfect. I'll leave it with you then and see if you wanna, if you think this is gonna,
Yeah,
as we would say, got some legs. And if if it has
Yeah.
got legs, then we can do a bit more work on it. Yeah.
yeah, makes sense. Thank you. Appreciate it. And we are at almost the top of the hour. Any other questions? All right. Everyone have a wonderful weekend, and we will talk again pretty soon.
Thank you.
Thanks.
Yeah, thank you. Yeah.
Thanks,
Bye.
everyone.
Thank you.
Bye.
Thank you, guys.